Taskmanager, two of the most powerful built-in tools in Windows for monitoring and managing your computer's performance. Let's start by opening Taskmanager. I'll right-click on the taskbar and select Taskmanager from the menu. You can also use the keyboard shortcut Ctrl plus Shift plus Escape, or press Ctrl plus Alt plus Delete and choose Taskmanager from the lock screen. Another quick method is pressing Windows key plus R, typing Taskmanager, and pressing Enter. If your Taskmanager opens in the simplified view, you'll see a More Details button at the bottom. Click that to expand the full interface. In Windows 11, the tabs are displayed as icons on the left sidebar. In Windows 10, they appear as tabs across the top. You'll see 7 main sections: Processes, Performance, App History, Startup Apps, Users, Details, and Services. Each serves a specific purpose, and we'll explore every one. Let's begin with the first and most frequently used section. Processes tab. The Processes tab is where you'll spend most of your time. It shows a complete list of everything currently running on your computer. This includes applications you have open, background processes, and essential Windows system processes. The list is divided into 3 sections: Apps, Background Processes, and Windows Processes. Windows processes are system critical and generally shouldn't be ended unless you know what you're doing. Look at the column headers: CPU, memory, disk, network, and GPU. These show the real-time resource usage for each process. At the very top, you'll see the total usage percentages for each resource. If your computer is running slowly, this is the first place to check. A quick way to identify the culprit is to click any column header. For example, clicking CPU sorts all processes by CPU usage from highest to lowest, instantly showing what's using the most processing power. Clicking memory does the same for RAM usage. This is one of the fastest ways to find resource hogs. If you find an application that's using too many resources or has become unresponsive, you can end it. Simply select the process and click End Task at the top. Alternatively, you can right-click and choose End Task from the context menu. Be careful, ending critical Windows processes can cause system instability. You'll also notice other options when you right-click a process. Create Dump File creates a memory snapshot that can be analyzed by developers or support teams. Open File Location takes you to the folder where the executable is stored, which is useful for identifying suspicious files. Search Online does exactly what it says, helping you research unfamiliar processes. On Windows 11, you may see a feature called Efficiency Mode. This reduces a process's resource usage by lowering its priority. When enabled, you'll see a green leaf icon next to the process. This is a great way to temporarily tame a resource-hungry application without closing it completely. At the top right, you'll also see a Run New Task button. This opens a dialog box where you can type a command to launch any application. This is especially useful for restarting Explorer, which we'll do later by typing explorer.exe. Performance tab. Now let's move to the Performance tab. This section gives you a real-time graphical view of your system's hardware components. On the left, you'll see a list of components: CPU, memory, disk, Wi-Fi or Ethernet, and GPU if you have one. Start by selecting CPU. The main graph shows CPU usage over time, and below it you'll see key statistics like utilization, speed, processes, threads, and handles. A useful trick: right-click the graph and select Show Kernel Times. This splits the graph into 2 colors, one for kernel processes and one for user processes. Kernel processes are system operations, while user processes are your applications. This distinction can help identify if the system itself is the bottleneck. You can also break down the CPU graph further. Right-click again and choose Change Graph to, then Logical Processors. This splits the graph into individual graphs for each logical processor core. If you see one core maxed out while others are idle, you know the issue is single-threaded performance rather than overall CPU load. Next, click Memory. This shows total RAM, used and available memory, speed, and the number of slots in use. The graph shows memory usage over time. High memory usage consistently can indicate you need more RAM. Select disk to see read and write speeds. Network shows send and receive activity for your internet connection. At the bottom of the Performance tab, you'll notice Open Resource Monitor. We'll explore that in detail later as it provides an even deeper level of analysis. App History tab. The App History tab tracks resource usage of applications over time. You'll see CPU time, network usage, metered network usage, and tile updates. This is primarily relevant for Windows Store apps and modern applications. Traditional desktop applications don't always appear here. If you need to clear this data, click Delete Usage History at the top. This resets the tracking and can be useful for testing or troubleshooting specific applications. For most users, this tab is less frequently used but can help identify apps that are consuming network bandwidth in the background over a long period. Startup Apps tab. Now let's look at the Startup Apps tab. This shows a list of all applications that launch automatically when Windows starts. The status column tells you whether each program is enabled or disabled. The Startup Impact column shows low, medium, or high impact on boot time. Many people find their computer takes a long time to start up, and unnecessary startup applications are often the cause. To improve boot speed, you can disable programs you don't need at startup. Simply select an application and click Disable at the top, or right-click and choose Disable. Be careful, you should not disable security software, driver utilities, or system processes. At the top right, you'll also see Last BIOS Time. This is the time taken by your BIOS or UEFI firmware to initialize hardware before Windows starts loading. A high BIOS time can indicate hardware issues or excessive peripheral devices. Users tab. The Users tab shows everyone currently signed into the computer. This is particularly useful in multi-user environments or when using remote desktop. Expand a user by clicking the arrow next to their name to see the processes running under their session, along with their resource usage. If you need to, you can right-click a user and choose Disconnect or Sign Out. However, be cautious as this will close all their open applications and force them to log in again. Details tab. The Details tab provides a more granular view of all running processes. Unlike the Processes tab, this one shows every single process with its process ID, or PID, which is a unique number assigned to each process. You'll also see username, CPU, memory usage, description, and status. You can customize this view by right-clicking a column header and selecting Select Columns. This opens a dialog with dozens of additional fields you can add, such as threads, handles, and CPU time. This is especially useful for IT professionals performing advanced troubleshooting. Right-click any process and you'll see options like End Task, End Process Tree, Create Dump File, and most importantly, Analyze Wait Chain. Analyze Wait Chain shows if a process is waiting for another process or system resource to complete. This is invaluable for diagnosing application hangs and deadlocks. If a process is stuck, Taskmanager will display a chain of dependencies, and you can end the blocking process to unblock the application. You can also set a process priority or affinity. Priority determines how much CPU time the process gets relative to others, and affinity sets which processor cores the process can use. These are advanced settings and should only be adjusted if you know the implications. Services tab. The Services tab lists all Windows Services background processes that run without a user interface. You can see the status of each service, running, stopped, or paused. This list is similar to the Services MMC console, which you can access by clicking Open Services at the bottom. Right-click a service to start, stop, or restart it. This can be very useful if a service has stopped unexpectedly or is using too many resources. However, be very careful when stopping services. Some are essential for system functionality. For example, Stopping the print spooler service will disable printing, and stopping Windows Update can prevent important security patches from installing. Resource Monitor. Now we come to Resource Monitor, which is the deeper, more detailed version of Task Manager's Performance tab. Let's launch it. There are two ways: click Open Resource Monitor at the bottom of the Performance tab, or press Windows key plus R, type ResMon, and press Enter. Resource Monitor opens with the Overview tab active. This gives you a summary of CPU, memory, disk, and network usage all in one view. You'll notice each section can be expanded or collapsed by clicking the header bar, giving you control over how much information you see. Let's start with the CPU tab. This shows each process, with columns for CPU usage, service name, thread count, and handles. You can sort by any column to quickly see what's using the most CPU. You also have the same Analyze Weight Chain option here for diagnosing blocked processes. The Memory tab is where things get really detailed. You'll see physical memory usage per process, including commit, working set, and peak. The physical memory bar chart at the top gives a visual representation of how your RAM is being used. Hover over the bar to see exactly how much is in use, modified, standby, and free. Look at the hard faults per second column. A hard fault is a memory access that requires reading from the disk because the data isn't in RAM. This is significantly slower than accessing memory directly. A few hard faults are normal, but if you see consistently high numbers, it indicates that your system is running low on physical memory. Think of RAM as your desk and the hard disk as a filing cabinet. Grabbing something from your desk is fast. A hard fault is when you have to get up and walk to the filing cabinet to find the file you need. If you're doing that constantly, your desk is too small for your workload, meaning you may need more RAM. Next is the Disk tab. This shows per process read and write activity, and more importantly, it shows which specific files are being accessed. This is incredibly useful for tracking down disk I/O bottlenecks. Sort by total bytes per second to see which processes are doing the most disk activity. Look at the disk queue length if available. This is the number of outstanding input-output requests waiting to be processed. A sustained disk queue length above 2 indicates that the disk cannot keep up with the demand, causing a performance bottleneck. This is common with traditional hard drives, especially during antivirus scans, Windows updates, or heavy file operations. Finally, the Network tab shows per process send and receive activity. You can sort by send or receive to find which applications are consuming the most bandwidth. Expand TCP connections to see detailed connection information, including local and remote addresses, ports, and connection states. This is valuable for detecting suspicious network activity that could indicate malware or unauthorized data transmission. Conclusion. Let's summarize everything we've covered. Task Manager is your go-to tool for ending unresponsive applications in the Processes tab, tracking real-time resource usage in Performance, managing startup items to speed up boot time, diagnosing process issues in details using PIDs and weight chains, and controlling system services. When you need deeper analysis, Resource Monitor provides more detailed information, CPU and memory per process, per file disk activity, and per connection network monitoring. As a quick troubleshooting workflow, if your computer is slow, start with Task Manager's Processes tab. Sort by CPU or memory to find resource hogs and end them if appropriate. If the problem persists, go to Resource Monitor to drill down into specific files being accessed or network connections being made. And finally, don't forget that Task Manager has settings you can customize. In Windows 11, click the gear icon at the bottom left to set your default start page, change update speed, and more. That concludes this complete guide to Task Manager and Resource Monitor. With these tools, you have everything you need to monitor, analyze, and optimize your Windows computer's performance. Thanks for watching, and happy troubleshooting.